This is a short video going through the distillation lab that we will do a dry lab from. As you remember from reading, a distillation lab is a way of separating materials based on their boiling points. Not all materials have the same, or liquids have the same boiling points. And so by heating those up and removing the liquid with a condenser, we can actually separate liquids. So above here, you're going to see a diagram of what a distillation apparatus looks like, and please read through the instructions. But further down is the part that I want to work with you. A couple of things, you'll notice that I have a demo video up here, as well as how does this process, this light blue text, which is where I'd like you to answer those questions. So wherever you see light blue text, that means you do need to answer that. The next part is I have here a pre-lab. In the pre-lab, it gives you just a little bit of a background or an example of what you should be seeing. So once I have plotted all my data, I notice that in my data here, I have various plateaus. The data that I have shows that over time, the temperature of the liquid that I had boiling, and keep in mind the liquid that we're talking about is right in here. That's where the thermometer is. So the liquid temperature increases, and as you notice, as it increases, at some point there's no longer an increase, okay? And this is the boiling point. That means that that liquid changes from a liquid to a gas, and that's why you don't see an increase in temperature, because it takes extra energy to get that liquid into a gas, and that extra energy comes from heat. So the first question that I'd like you to ask is, how many different liquids are originally in the mixture, and explain how you know. So I'm going to give you a moment to think about it, pause the video, come up with an answer, type this in, and then I'll give you the answer. So hopefully what you came up with was that there are three different liquids. We have one boiling point at this point right here, where the temperature has not increased because all that liquid the first liquid has a boiling point and has changed from a liquid to a gas. You notice that over here I have another plateau. This is yet again the boiling point of a second liquid. And then the last one is the boiling point of a third liquid. So here we had originally a mixture of three different liquids, and you had three different boiling points. They were separated based on their boiling point. So now, which liquids are those? So the first plateau you notice looks like it's about in the 58-ish, 56-ish range, and that's when you start looking up here at some known values. Through laboratory experiments, we know that 2-propanol seems to, the acetone seems to boil at 56 degrees. And it looks like right around here, that's pretty close to 56 degrees, that this must have been all the acetone that boiled away. So the first liquid is acetone based on the boiling point, and we looked at the chart here for that. Now the second liquid, I'm going to have you guess what that second liquid is. This is the boiling point. If you said cyclohexane, you're absolutely right. It has an 80-degree centigrade boiling point, and this looks like it's pretty close to 80 degrees. Lastly, the boiling point is, for this one, looks like it's close to 100. When we look at our table, we see that 100 is water. So in this mixture, I had three liquids. I had acetone, I had cyclohexane, and water. And these were separated based on their boiling points. So whichever one had a faster boiling or a lower boiling point, it evaporated, went from a liquid to a gas sooner, was removed with that condenser. Then we had cyclohexane, and lastly water. So you're going to be doing a similar lab with this here. So this lab here, you have all the data table. The way that I set it up this is the time it took, the temperature that you have with the boiling points, and appearance of the distillate. This is what did the liquid look like when it was in this little beaker right over here. Here's the distillate beaker. You see that small beaker, and you notice that in the beginning there is no distillate, and then you have this color. So what you're going to be doing is you're going to be creating a time versus temperature graph using the data. And so what that's going to be is that you're going to open up your Google spreadsheet. So let me switch screens and do that. So I will open up a Google spreadsheet. Cancel. Let's try one more time. And I'm going to increase this the size of this screen. Let me pause. So for the first column, what you're going to do is you're going to enter in your time. You have 0 time. Then you have, excuse me, let me continue that. We have 0 time. Then we have, I believe, 0.5 seconds and 1 second, and so forth. The next time, for the next part, what you're going to do is you're going to enter in the temperature. And I have forgotten what the temperature is, so I'm randomly putting some temperatures in. So let's say these are the temperatures. You're going to continue on entering all your data. And then if you remember, then to do a graph on Google Spreadsheet, what you're going to do is you're going to highlight your first column so it's shaded. You're going to click the Insert Chart button. From there, you're going to go into Select Ranges. You're going to add another range, in which case you can highlight the other area, and press OK. Then you're going to move on to a scatter graph, and this is exactly like you've done in physics. And here you have your data. You're going to customize it. You're going to add a title of some sort right over here. You're going to write a title of the axes. Here's where you actually change the title and for vertical. And then you actually run the graph and insert it, please, into the document. So this is something I know you've done quite often in physics, so it's just more of a refresher. And I'd like to have this then submitted into Schoology. Have a great day, and I will see you next class.